Okay, so we are graphing rational functions, and here's number 2. These are the ones that we have to factor, and let's see, x squared here, this one, number 2, f of x is equal to x squared plus 3x minus 4 over x squared plus 2x minus 3. Okay, this is an easy one. We don't have a leading coefficient. We still always look for a GCF, right? But there's no GCF here. And now we got to find out how this factors out. Let's see. F of x is equal to x squared plus 2x minus 3 and x squared plus 3x minus 4. Well, this one's going to be x plus 3, x minus 1. This one's going to be x plus 4 and x minus 1. Of course it's going to be that. Why? Because, right, this is going to replace this one. This is going to replace this one. And now when you look at this, right, this is where they're going to cancel out, right? This matches, right? The ones that match in the numerator and the denominator, they're going to cancel out. But, and we're going to be left with this, right? F of x is equal to x plus 4 over x plus 3. Okay. Then eventually we're going to graph this. But for these parts, in this part, in this here is where the whole will exist. Whole will exist for what value of x? For what value of x? Well, again, whatever it is, put x, in this case, put x minus, put it equal to 0. Put it equal to 0 and solve it. Well, you move the negative 1 over. That gives you x equals positive 1, right? Is it true that if I put a positive 1 right here, it'll give you a 0? Yes. 1 take away 1 will give you a 0. And then again, 1 take away 1 will give you a 0. And that's the coordinate for the value of x, where the whole will exist. Whole will exist at what? At x is equal to positive 1. Now, that's only the x coordinate. I need to go ahead and substitute this into the formula to find the y coordinate. So I'm going to copy this, right, because this part that's left over, f of x is equal to x plus 4 over x plus 3. I'm going to have to substitute for the x, right? Substitute. And right now what you're finding is the coordinates of where the whole is going to be. I already know it's the x coordinate is 1, and then this is going to be what? Well, that's your y. Y is equal to, that's going to be 1 plus 4 on the top and 1 plus 3, right? X is 1. X is 1. I got to put a 1 right here for the x. That's going to give you 5 over 4. The value of y is 5 over 4. Here it is. You found the coordinates of the whole, right? So make sure you get that first before you move on to everything else. Here's where the whole is going to be, right? You got the x coordinate, substitute it in here. You get the y coordinate. So the whole will be at what? X is 1 and y is 5 over 4. And 5 over 4 is, I think, 1.25. Let's see. You got to know exactly where this 5 divided by 4. 5 divided by 4 is equal to, yeah, 1.25. A little bit past 1, right? 1.25. So I know this is 1.25. But that's the coordinate for the whole. We'll come back to the whole, to the coordinate there. Okay. So again, here, This is where you go back and you find the asymptotes, right? Here I got one asymptote where this will give me a 0 at x is equal to -3 as an asymptote. And then you look at the coefficients there, that's 1 over 1, so that's going to be y is equal to 1. That was discussed in worksheet 1. So now I got all the information. So I'm just going to graph this one real quick. Here's y. Here's x. 1, 2, 3. 1, 2, 3. -1, -2, -3. -1, -2. Oops. -3. I got an asymptote at x is equal to -3. That is x, -3. I got an asymptote right here. Right? And that is a vertical asymptote because it's vertical. Y is equal to 1 is the other one here. Y is equal to 1 right here. That's the other asymptote. There it is. And the coordinate of the hole will give me the information to know where the graphs will exist, right? So, where is the hole? The hole is at 1 on the x, and 5 over 4 is 1.25, so that's 1 and 1.25. That means the hole's right here, right above 1. Right? It's 1.25 is 5/4. The hole is here. Well, that just tells me that what? If the hole is in this quadrant, that means that the curve has to go here, right? Because the hole has to be on one of the curves. And if one of the curves is here, the other one, oh man, I ran out of paper, but the other one is going to be on this quadrant, right? This side over here, right? There's two of them. They always come in pairs. They're opposite and they're diagonal. Okay. For the other ones, I'm not going to graph and do the whole thing. I'm just going to do the factoring and finding the coordinates of the hole. After that, this part that's left over is like worksheet 1. Okay, I'll do that in the next video.